Hi, my name is William Garrett Burnham, and today I'm going to talk to you about the benefits of having an effective parts inventory management system and implementing that system. So here's some industry statistics. So in the United States alone, there are over 100 certified passenger airlines that operate over 11 million flight departures per year, which equates to over 745 million passengers just in 2006 alone. So when carrying all these passengers, it generates $160 billion in total airline revenue. So it is extremely important to keep these aircraft flying as long as possible for as much as possible. The airline industry as a whole accounts for a large portion of the United States GDP, coming in at 8% of the GDP. So in order to keep the aircraft flying, it's paramount that the MRO works with their parts suppliers to allow transparency through the supply chain, let them know what they need, as well as letting the MROs know what the parts distributors need to do to keep up with the demand for the parts. So it costs $19 billion annually to replenish and keep their spare parts inventory stocked at the MROs, all in hopes to eliminate grounded aircraft scenarios, as well as coordinate parts for scheduled maintenance. It can cost airlines up to $20,000 per day for each aircraft on the ground incident that occurs. So I cannot stress the importance of coordinating effective inventory management in order to keep the aircraft off the ground to generate revenue for the airline. So it's estimated that the airlines spend approximately $110 million on poorly positioned spares. So when an aircraft goes down in a certain region or pulls into a certain facility, it's not guaranteed that they will have the part if an unforeseen event happens. So as an inventory management specialist, it's important that they coordinate and work with the parts distributors to analyze what parts they may need and be able to stock those parts that the management believes they may need in the future. So how they can do this is through data sharing. So they have aggregate data collection, which can help between the parts distribution channel and the MRO facility, and they can generate trend analysis and data that is aggregated between the OEM and parts distributor, which can provide a total quality view across all the segments within the parts distributors and allows for more accurate forecasting on both ends, so the MROs are able to stock the parts that they believe they may need. One of the other ways they do this is through early warning notification, which can improve operator and third-party MRO integration of master parts lists to spares planning in order to get parts to the MRO before they run out. And then there's also aggregate fleet collection between the MRO and the airline fleet. So it's important for them to also study the MROs, to study their aircraft to see what exactly they need, whether it be a scheduled maintenance or unscheduled maintenance, so they can determine what parts they may need and study that, and then transfer that data to the parts distributors so they know what they're working with, so they can generate accurate forecasts and supply parts to them and there's no shortage. And then this also helps to eliminate bloated inventory systems, excess waste, stagnant inventory, all of which can just bleed on their asset balance sheet and essentially just have a collection of wasted, unused parts sitting around. So one of the other ways that they can utilize cutting-edge technology is through RFID systems, so radio frequency identification tags. And these tags are on the parts themselves. Boeing and Airbus are using RFID systems, and it's becoming very prevalent in the industry. They're sharing the codes between the whole RFID system. So since they do use a lot of the same spare parts between both aircraft, they have agreed to utilize the same codes for each part. So that is going to make it much more simplistic when they're trying to find parts, whether it be a Boeing or an Airbus aircraft. Some of the benefits of this is that information can be stored on the RFID system on the chip, which is on the part, and that is scanned by a handheld device or a stationary computer and can help improve the MRO and the parts distributor channel, which improves their parts traceability, which ultimately leads to reduced cycle times and results in faster in-service problem solving. The tags can be read anywhere along the way by handheld or stationary device, and it helps tracking the parts, and they don't have to scan anything, so there's no reason for there to be a barcode reader or anything like that. They just have to stand within a certain predetermined distance, which is typically 3 to 4 feet of the parts, and they'll be able to pick that up through the RFID tag. And this helps during cycle counts. It eliminates the necessity for human error that can be problematic. You know, if they're counting parts and somebody inputs data incorrectly, the RFID system helps to negate that, and it almost becomes a non-issue at that point since it is all computerized. It also helps to limit unsuspected or unapproved parts with the RFID system, so it authenticates the part that's being installed on the aircraft, and they can also do pre-checks before the flight, such as determining that there's a life jacket underneath all of the seats, which will have an RFID system on it, so the mechanic can walk on board with his handheld device, see that through his handheld device that there is a personal flotation device under each seat, and that eliminates the need for the mechanic to then walk around and physically verify under each seat and location that there is a handheld device, because he's able to see it on his handheld monitor. So it saves a lot of time and improves parts traceability. So this is a graph of the supply chain disbursement through the different types of communication channels. So on the left, there's a bloated and wasteful supply chain consisting of stagnant parts that are not being utilized and costing the MRO money. The MRO has these stagnant parts around in hopes to combat an aircraft on the ground event. However, all these parts sitting around and not always at the correct location can prove a costly endeavor for the MRO. The graph on the right exemplifies an ideal supply chain between the MRO and the parts distributors. This level of autonomy adds additional insurance through the use of effective parts inventory management and communication between both parties. The MRO and suppliers need to communicate effectively in order to have a supply chain that looks like this, rather than a supply chain that looks like this one over here. So they want just enough parts to meet their supply and demand, and this is all done through transparent communication on both ends. And when there's not transparent communication occurring, whether it be the MRO looking into the parts distributor's inventory or vice versa, so they can accurately forecast demand, this can occur. And ideally, we would want this type of setup here. So it's going to eliminate waste, and they get just what they need. And all at the same time, through analysis and data collection, they're able to evaluate the parts that they use most and be able to order that in hopes to negate an aircraft on the ground situation, which can be an unexpected event. With the implementation of effective parts inventory management, it can save both the MRO and the parts distributor a large amount of money if they are able to work smarter and not harder. That concludes my presentation, and I thank you for your time.